Addressing premature tape lamp failures requires a systematic approach, considering several potential causes. These can include power quality issues, lamp or ballast defects, environmental factors, installation errors, and other miscellaneous influences. Firstly, power quality issues are a prime suspect. High voltage spikes or surges can damage lamps. Voltage fluctuations stress the lamp components, and harmonic distortion introduces unwanted currents that can overheat ballasts and lamps. Full grounding can also lead to erratic voltage behavior. Secondly, lamp or ballast defects can play a role. Faulty lamps might have weak electrodes within glass susceptible to early failure. Substandard ballasts may lack adequate voltage regulation, leading to lamp stress. Thirdly, environmental factors can contribute. Excessive heat or cold can affect lamp performance and lifespan. Moisture or condensation can cause short circuits and corrosion. Vibration can damage lamp filaments and connections. Fourthly, installation errors can be a factor. Improper lamp seating or orientation can lead to poor contact and overheating. Loose ballast connections can cause arcing and voltage drops. Over-tightened lamp bases can damage the lamp. Finally, other factors could be involved. Reactive loads from nearby equipment can distort the voltage waveform. Mismatched ballasts or lamps can cause incompatibility issues and premature failure. Aging of lamps or ballasts naturally leads to reduced performance and eventual failure. To effectively investigate and troubleshoot these issues, a structured approach is necessary. Firstly, conduct an electrical inspection. Check the voltage and current levels at the affected fixtures to identify any abnormalities. Inspect the grounding system and neutral connections to ensure proper grounding and minimize voltage imbalances. Examine the ballast and wiring connections for any signs of damage or looseness which could indicate poor connections or overheating. Secondly, perform a lamp analysis. Examine the burned lamps for signs of arcing or blown electrodes, which can indicate voltage surges or excessive current. Check the pinhole locations and compare them to the fixture's ballast type and wiring diagram to identify any inconsistencies or mismatches. Thirdly, conduct a power quality assessment. Use a power quality analyzer to measure voltage spikes, fluctuations, and harmonic distortion. These measurements can help pinpoint specific power quality problems. Check the electrical system for any nearby equipment that may be drawing excessive reactive loads, which could be contributing to voltage distortion. Fourthly, conduct a fixture examination. Inspect the fixtures for any signs of heat buildup or moisture ingress. Check the lamp seating and orientation to ensure proper contact and prevent overheating. Based on the findings of the investigation, implement the following recommendations. Replace any faulty lamps or ballasts identified during the troubleshooting process. Use high-quality replacements that meet or exceed the original specifications. Improve power quality by installing voltage regulators, surge protectors, or harmonic filters. Voltage regulators can stabilize the voltage supply. Surge protectors can protect against voltage spikes. Harmonic filters can reduce harmonic distortion. Consider using higher quality lamps and ballasts with improved durability. These components are designed to withstand voltage fluctuations and other stresses. Ensure proper installation of fixtures and lamps following manufacturer's instructions. This includes proper lamp seating, secure wiring connections, and appropriate ballast selection. Monitor the electrical system regularly for any changes or anomalies that could contribute to lamp failures. This includes periodic voltage and current measurements, visual inspections of fixtures and wiring, and power quality monitoring. Further elaborating on power quality issues, it's important to understand the specific characteristics of each type of disturbance. Voltage spikes are short duration, high amplitude voltage increases that can damage sensitive electronic components, including lamp ballasts. Surge protectors can help mitigate the effects of voltage spikes by diverting excess voltage to ground. Voltage fluctuations, such as sags and swells, can cause lamps to flicker, dim, or fail prematurely. Voltage regulators can help stabilize the voltage supply and prevent these fluctuations. Harmonic distortion is the presence of unwanted frequencies in the voltage and current waveforms. These harmonics can cause overheating of electrical equipment, including ballasts and lamps. Harmonic filters can help reduce harmonic distortion by filtering out the unwanted frequencies. Poor grounding can lead to voltage imbalances and increase susceptibility to voltage spikes and fluctuations. Ensuring proper grounding is crucial for protecting electrical equipment and preventing lamp failures. When examining lamps for signs of failure, pay close attention to the appearance of the electrodes. Blown electrodes indicate a sudden surge of current that exceeded the lamp's capacity. Arcing can cause pitting and discoloration of the electrodes. The location of the pinhole on the lamp can also provide clues about the cause of failure. Pinholes near the electrodes often indicate voltage stress or excessive current. Pinholes in the middle of the lamp may indicate manufacturing defects or environmental factors. When selecting replacement lamps and ballasts, it's important to choose components that are compatible with the existing electrical system. Check the voltage and current ratings of the lamps and ballasts to ensure they match the system requirement. Consider using energy-efficient lamps and ballasts to reduce energy consumption and lower operating costs. When installing lamps, make sure they are properly seated in the fixture. Loose connections can cause arcing and overheating. Follow the manufacturer's instructions for lamp orientation and tightening. When installing ballasts, make sure the wiring connections are secure and properly insulated. Loose connections can cause arcing and voltage drops. Use the correct wire size and type for the ballast connections. Regularly monitor the electrical system for any changes or anomalies that could indicate potential problems. Check the voltage and current levels at the fixtures to ensure they are within the normal operating range. Look for signs of flickering, dimming, or unusual noises from the lamps or ballasts. Inspect the wiring and connections for any signs of damage or overheating. By taking these steps, it's possible to identify and address the causes of premature tape lamp failures and prevent future problems. This systematic approach combines electrical inspections, lamp analysis, power quality assessment, and fixture examination to provide a comprehensive understanding of the issue. Implementing the recommended solutions, such as replacing faulty components, improving power quality, and ensuring proper installation, can significantly extend the lifespan of tape lamps and reduce maintenance costs. Furthermore, consider implementing a preventative maintenance program that includes regular inspections of the lighting system. This program should include checking the voltage and current levels, inspecting the wiring and connections, and replacing lamps and ballasts before they fail. A preventative maintenance program can help identify potential problems early and prevent costly repairs. In addition to the technical aspects, it's also important to consider the human factors involved in lamp failures. Ensure that maintenance personnel are properly trained on how to install and maintain tape lamps and ballasts. Provide them with the necessary tools and equipment to perform their job safely and effectively. Encourage them to report any problems or concerns they may have about the lighting system. By addressing both the technical and human factors, it's possible to create a comprehensive approach to preventing premature tape lamp failures. This will not only reduce maintenance costs but also improve the overall quality of the lighting system and create a more comfortable and productive work environment. Let's also consider the impact of lighting controls on lamp life. Lighting control systems, such as occupancy sensors and dimming systems, can reduce energy consumption by turning off or dimming lights when they are not needed. However, some lighting control systems can also shorten lamp life if they are not properly designed or installed. For example, frequent switching of lamps can cause premature failure. Dimming lamps to very low levels can also shorten their lifespan. When using lighting control systems, it's important to choose systems that are compatible with the lamps and ballasts being used. Also, be sure to program the systems to minimize switching and dimming, especially to low levels. Finally, consider the impact of external factors on lamp life. External factors, such as temperature, humidity, and vibration, can affect lamp performance and lifespan. Extreme temperatures can cause lamps to fail prematurely. High humidity can cause corrosion of electrical components. Vibration can damage lamp filaments and connections. When installing lamps, consider the environmental conditions in which they will be operating. Choose lamps and ballasts that are designed to withstand the specific environmental conditions. Also, take steps to protect the lamps from external factors such as temperature, humidity, and vibration. By carefully considering all of these factors, it's possible to significantly extend the lifespan of Tate lamps and reduce maintenance costs. Remember to prioritize a systematic approach that combines electrical inspections, lamp analysis, power quality assessment, and fixture examination. Implementing the recommended solutions, such as replacing faulty components, improving power quality, and ensuring proper installation, is crucial. Don't forget the importance of preventative maintenance, proper training, and the impact of lighting controls and external factors. Through a comprehensive and proactive approach, the problem of premature Tate lamp failures can be effectively addressed, leading to a more reliable, efficient, and cost-effective lighting system. Think about the specific symptoms observed: lamps burning on the ends with a pinhole near the electrodes. This strongly suggests a high voltage issue or a problem with the lamp electrodes themselves. The fact that it's only on one side of the building is a key piece of information. It points towards a localized electrical problem rather than a building-wide issue. The fact that the lamp and ballast reps haven't seen this before doesn't necessarily rule out common causes. It could be a combination of factors or a subtle electrical anomaly. To narrow down the possibilities, start by thoroughly investigating the electrical panel that feeds the affected side of the building. Check the voltage at the panel and at several points along the branch circuit. Look for any signs of voltage imbalance between phases. Use a multimeter to check the voltage under different load conditions. Also, inspect the neutral and ground connections at the panel and at the fixtures. Make sure they are clean, tight, and properly sized. Use a power quality analyzer to monitor the voltage and current waveforms over a period of time. Look for any voltage spikes, sags, swells, or harmonic distortion. Pay particular attention to transient events that may be occurring intermittently. Check the total harmonic distortion, abbreviated as THD, of the voltage and current. High THD can indicate the presence of nonlinear loads that are injecting harmonics into the system. Also, investigate the grounding system. Make sure it is properly connected to earth ground. Check the ground impedance to ensure it is within acceptable limits. A high ground impedance can increase the risk of voltage surges and electrical noise. If possible, try to isolate the affected side of the building from the rest of the electrical system. This can help determine whether the problem is originating within that section or being introduced from elsewhere. Check for any unusual electrical equipment or loads that may be connected to the affected side of the building. Look for equipment that is known to generate harmonics or voltage transients, such as variable frequency drives, switching power supplies, or arc welders. If you suspect that a particular piece of equipment is causing the problem, try disconnecting it to see if the lamp failures stop. Examine the fixtures themselves for any signs of damage or defects. Check the lamp holders for cracks, corrosion, or loose connections. Make sure the ballasts are properly mounted and grounded. Inspect the wiring inside the fixtures for any frayed insulation or loose connections. Also, consider the possibility of electromagnetic interference, abbreviated as EMI. EMI can be generated by nearby electrical equipment or radio transmitters. It can interfere with the operation of electronic devices, including lamp ballasts. Try shielding the fixtures or rerouting the wiring to reduce the effects of EMI. If you are still unable to identify the cause of the problem, consider hiring a qualified electrical engineer or power quality specialist to conduct a more thorough investigation. They have the expertise and equipment to diagnose complex electrical problems. Finally, document all of your findings, including voltage measurements, power quality data, and fixture inspections. This documentation can be valuable for future troubleshooting efforts. The recommendation is to replace faulty components, improve power quality, and ensure proper installation. This approach is aimed at creating a robust and reliable lighting system. Remember that power quality problems can be complex and difficult to diagnose. It may take some time and effort to find the root cause of the lamp failures. Be patient, persistent, and methodical in your investigation. The fact that the problem is only on one side of the building is a crucial clue that should guide your troubleshooting efforts. Good luck in solving this issue. Also, it might be a good idea to check the building's history. Have there been any recent changes to the electrical system or the equipment connected to it? Have there been any reports of similar problems in the past? This information can provide valuable insights into the cause of the lamp failures. It's also important to communicate effectively with the customer. Keep them informed of your progress and explain the steps you're taking to solve the problem. This will help build trust and ensure that they are satisfied with your service. Remember to follow all applicable electrical codes and safety regulations when working on the electrical system. Wear appropriate personal protective equipment and take precautions to avoid electrical shock. If you are not comfortable working on electrical equipment, hire a qualified electrician to do the work for you. Troubleshooting electrical problems can be challenging, but it can also be rewarding. By following a systematic approach and using the right tools and techniques, it's possible to identify and solve even the most complex electrical issues.